Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2018, 10B Problem 15, or the 12B Problem 11, and it deals with geometry. I hope you guys enjoyed this video, and let's get started. The problem states a closed box with a square base is to be wrapped with a square sheet of wrapping paper. The box is centered on the wrapping paper with the vertices of the base lying on the midlines of the square sheet of paper as shown in the figure on the left. The four corners of the wrapping paper are to be folded up over the sides and brought together to meet at the center of the top of the box, point A in the figure on the right. The box has base length W and height H. What is the area of the sheet of the wrapping paper? Well, basically, the first step to solve this problem is to understand what we're looking at the graph on the left. So we see that when you fold the wrapping paper over the sides, essentially, this would be the height, because it tells us that the four corners are going to meet at the center, and it forms this triangle right here. So technically, it would be this. You would fold this section, which would be the height, so it would wrap neatly along the sides of the box, and then this part, this triangle right here, reflects this triangle, which would be at the top. So essentially, the area of the sheet of the wrapping paper is just the surface area of the box plus all of these small triangles. Because the green part that I highlighted, all of this would be covered by the box. So that would just be the surface area of the box. So we know that the surface area of the box would be W squared, which is the area of the base, and then we have the top and the bottom, so it would be 2W squared plus the four sides, and the sides have an area of W times H, and it's four of them, so it'd be 4WH. And then the triangles, well, we know that this is H and this would also be H because that's the height of the box. So that's basically essentially the base and the height of this triangle. So the area of that would be 1/2 H squared, and then there are four of these triangles, so you multiply by 4 to get 2H squared. So together the paper's area would be 2W squared plus 4WH plus 2H squared. And then we can factor this to get 2 times W plus H quantity squared. So the answer is A.